So a lot of times when you learn how to solve equations, you can think about it as reverse PEMDAS, so the reverse of the order of operations. So if my order of operations is normally PEMDAS, then I know that SAD MEP is what I can think about when I'm doing the reverse, when I'm trying to figure out what a missing variable is. And if I follow the reverse order of operations and then I go back and check my answer following the order of operations, I'll get the right answer. So it makes sense for us to do the reverse. So what I'm going to look at here is trying to follow SAD MEP when solving an equation for an unknown variable. So what I'm going to look for first on both sides of my equation is addition and subtraction. So I'm going to draw my line. And when I'm looking at this solving radical equations, I know that the way to get rid of a radical is by using an exponent. So we know that subtraction and addition are opposites, division and multiplication are opposites, and exponents are opposites with their root. So hopefully doing this will make that make a little bit more sense, because this is a square root symbol, our little check sign. In order to get rid of a square root, we have to square it. But I'm getting ahead of myself. So looking at both sides, I do have addition and subtraction, but that is beneath my radical. So that isn't going to happen until I am able to address the exponents of reverse order of operations. So what I need to look at then is division or multiplication. I know that there is multiplication beside this 2, because if there is no symbol, then multiplication is the assumed operation. So in order to get rid of this times 2 beside our square root sign, I'm going to divide by 2. If I do that to one side, I need to do it to the other. Those 2's cancel out, and I'm going to bring down my square root of 2r plus 5. And this is going to be equal to 3, because 6 divided by 2 is 3. Now that there is nothing left to simplify on this side before exponents, now I can use exponents. So we did all the subtraction, addition, division, multiplication that we could. And so now I can get rid of the square root sign. In order to get rid of a square root sign, I need to square it. So if I do that to one side, I need to do it to the other. The squared version of a square root just cancels out the sign. So I'm left with what is in the inside. And 3 squared is 9. And now I am down to a regular looking 2-step equation. I know that I need to draw my line, which has already been done. I'm going to subtract 5 from both sides. Those plus 5 and minus 5 cancel out. I'm left with 2r equals 4. I'm going to divide both sides by 2, and I get r equals, don't know why I wrote that. R equals 2, because 4 divided by 2 is 2. And because this is kind of a trickier type of problem, what I'm going to do is I'm going to go back to our original equation, and I'm going to plug in for r the number 2. So where this r is, we're replacing it with our solution to make sure that it was correct. So we have 2. I'm I'm going to follow my order of operations. So I'm going to do these parentheses first, and I'm going to do 4. I know that this whole thing that's beneath the radical is assumed to be in parentheses as well. So I am going to then add 4 plus 5. And I get the square root of 9. And the square root of 9 is 3. I don't know why I wrote that twice. Oh. And 2 times 3 equals 6, which is what we wanted to get. So I know that I did it correct because when I went back to check my answer, it was correct. You can also just directly type it into your calculator. So if I had 2 square root 2 plus 5, I get 6. So that is correct. This one's a little bit easier to look at, this next problem here, because we have a square root on both sides. So that's the first thing that I can start with. So if I square both sides to get rid of my square root symbol, since that has to be done before I can work within the square root, I square this side and I'm left with n plus 5. When I square this side, I'm left with 5n minus 11. And then I have a totally normal multi-step equation. I'm going to do my squares around my variable terms, my circles around my constants. Should have already drawn my line. We're going to add or subtract to make our variable terms on one side. Then I'm going to add or subtract to get the constant only on the other side. And now I can do multiplication or division to get n totally by itself. And that's it.